Assalamualaikum and hi, we are from group 8 are going to present about ANOVA. My name is Elmira. Okay, let's proceed to what is ANOVA. ANOVA allows a comparison of more than two groups at the same time to determine whether a relationship exists between them. The result of the ANOVA formula, the F statistic, also called the F ratio, allows for the analysis of multiple groups of data to determine the variability between samples and within samples. Okay, when we should use the ANOVA? The ANOVA is used when we want to compare several population means simultaneously. There are two types of ANOVA, which is one-way and two-way. One-way has one independent variable with two levels, while two-way has two independent variables and it can have multiple levels. That's all from me, thank you.
So next, how to use it. First, when we want to use the ANOVA procedure, we will illustrate the ANOVA procedure using the 5-step approach because the computation of the test statistic is involved. The computations are often organized in an ANOVA table. The ANOVA table breaks down the components of variation in the data into variation between treatments and error or residual variation. Statistical computing packages also produce ANOVA tables as part of their standard output for ANOVA, and the ANOVA table is set up as follows. So this is the table. We can see that all the data that we need in ANOVA is in the table, which is source of variation. We have between treatment, error, total. We calculate the sum of squares, degrees of freedom, mean squares, and F. Where this is the meaning of the symbol here. Okay, next we go to the example. So the example is about a clinical trial is run to compare weight loss programs, and participants are randomly assigned to one of the comparison programs. So this is the trial. Low calorie, low fat, low carbohydrate, and control. So the question is there a statistically significant difference in the mean weight loss among the 4 diets? And then we will use the ANOVA using the 5-step approach. So for the first step is we set up the hypothesis and determine level of significance. This is H0, H1, and this is the significant level. And step 2, select the appropriate test statistic. The test statistic is the F statistic for ANOVA. This is the formula to calculate F. And then step 3, set up the decision rule. So in order to determine the critical value of F, we need the degrees of freedom, which is the F1, the F2, the F1, and the F2. And this is the formula for the F1 and the F2. So the decision rule is reject H note if F is bigger and same with 3 and 3.24. And step 4 is compute the test statistic. To compute the test statistic, to organize our computation, we complete the ANOVA table first. In order to compute the sum of squares, we must first compute the sample means for each group and the overall mean based on the total sample. So this is to compute the test statistic. First, we calculate the SSB. Here, SSB. We calculate first SSB, and then we will calculate SSE. We will get the SST. With this, and then we calculate this, we will get this, and this. With this, we will conclude that either want to reject or not the hypothesis. So for step 4, we will first calculate the SSB. The SSB is 75.8. The SSE, this is the formula. SSE requires computing the squared differences between each observation and its group mean. We will compute SSE in parts. For participants in the low, so this the participant in the low calorie diet. For SSE, we will calculate it one by one, by category, by part. So this for low calorie, and SSE for low calorie is 21.4. For low fat diet is 10. SSE for low carbohydrate diet is 5.0. For control group is 10.6. So the total for SSE, we sum up all from all the part, we get 47.4. So we can now construct the ANOVA table. We put all the data we calculate just now in the table. So we calculate this. We got this. So step 5, just conclusion. We reject the hash note because 8.43 is bigger than 3.24. This is the F. We will reject because it's bigger than 3.24. That's all for how to use ANOVA. Thank you.
Now I will show how to use ANOVA using Excel. Click File and Options, and then click Add-ins, Analysis to Pack, and click Go. Tick on the box and click OK. When you click the data, you can see that there is a data analysis option. Click on it and this will come out. Select ANOVA single factor and click OK. Now this will come out, and then you have to highlight all the data. Next, click OK on the previous toolbox. It will all come out on the second sheet, and now we will copy and paste it to the first sheet to make it easier to view. Next, we will build two hypotheses. Now, this is F value and this is critical value. F value is smaller than critical value, so we fail to reject null hypothesis.
For the conclusion, we can conclude that for every test using the same principle, which is use the variability of the data and the amount of the data. We do not use t-test because it is simple and less daunting, but we will use ANOVA when we want to test the hypothesis when there is significant differences between the mean of more than two groups, and whether at least one of them differs from another. It is obvious that we need a better method than conducting t-tests. ANOVA will allow us to compare the treatment means simultaneously and avoid the build-up of type of error.